Hello, and welcome to the video on finding the instantaneous rate of change when I have a rational function at a specific x value. So for this one, I want to compute the instantaneous rate of change of f of x is equal to 1 over x plus 3, and I want to find that when x is equal to 2. Now 2 is in the domain of the original function, so I'm able to go through the process with this. Now here we're going to recall that to find the instantaneous rate of change of a function, we find the f of a plus h minus f of a all over h, difference quotient. And then once we have that simplified, we are going to plug in 0 for h, and then that will give us our instantaneous rate of change of that function there. Now the a that they're talking about in this formula is your specific x value. So in our example, our a is equal to 2. Now recall to find this difference quotient, and we'll go ahead and write it one more time where we have 2's where the a's are. So this is f of 2 plus h minus f of 2 all over h that we're looking at for this problem. And we do this in pieces. The first piece is to find f of 2 plus h. So we'll do that over to the side. Remember, to find f of something, we go to the functions rule and take out the x and put in that something. And here that something is the 2 plus h. So we are going to calculate f of 2 plus h by going to where the x's are, take that out, and put in the 2 plus h instead. This gives us f of 2 plus h is equal to 1 over, and my parenthesis groupings, I don't have an action on it as like an exponent or a multiplication or any function acting on it. So I really just have 2 plus h plus 3 in the denominator, which is 5 plus h. That expression 1 over 5 plus h goes where the f of 2 plus h is. We'll do that in just a minute. Next up, we want to look at the f of 2. So f of 2, we're going to go to our function and take out the x's and put in 2 instead. So I have 1 over, take out the x and put in 2, and then plus 3. So my f of 2 is going to be 1/5. And that 1/5 is going to go where the green shaded expression is. So we have take out the f of 2 plus h and put in our expression 1 over 5 plus h minus take out the f of 2 and put in our 1/5, and then that's all over h. Now this is not simplified enough for me to be able to take out the h's and put in zeros yet. And what we need to do here is we need to look at this complex fraction and rewrite it without the denominators in the numerator. So when I think about the fractions in the numerator, the length of those fraction bars are a grouping symbol. So there's a grouping of 5 plus h, and then the other denominator is 5. So my lowest common denominator of the fractions in the numerator is 5 plus h times 5. And I want to multiply the numerator by that 5 plus h times 5, and then think of that over 1 so that you can see how to multiply it through. But that would change the fraction. In order to make sure that I have the same original expression, I also need to multiply the denominator by that 5 plus h times 5. And I'm not going to put that one over 1. I certainly could, but I guess actually let's go ahead and put that over 1 and recall that my h is over 1 to realize that's in the same line of multiplication. Now when I multiply this 5 plus h times 5 times the first fraction, the 5 plus h's will cancel and I'll just be left with 5. When I multiply that 5 plus h times 5 times the second fraction following that minus, the 5's will cancel. And so they'll remove as a common factor pair and just leave me that parenthesis of 5 plus h. and then that's all over. And in the denominator, we don't want to multiply that out. We actually want to leave that factored as h times 5 plus h times 5. Next, in the numerator, I have some more simplification to do. This -1 precedes a two-term expression. So we need to multiply the -1 through the parentheses to remove those. So I have 5 and then minus 5 minus h over my h times 5 plus h times 5. Then combining like terms in the numerator gives me a -h over my h times 5 plus h times 5. And we're going to scoot this up a little bit, make it a little bit smaller to be able to still see the top. When I look at the numerator, I notice that that's -1 times h, and a common factor of h in the denominator. Those common factors of h will remove and leave me a -1 in the numerator. So I have -1 over the parentheses 5 plus h times 5. So there's where I have it in its simplest form. But now to find the instantaneous rate of change, we want to set h equal to 0. So in that expression, take out the h and put in 0 instead. I have my -1 over 5 plus, take out the h, put in 0, and then times 5. 5 plus 0 is 5, and 5 times 5 in the denominator is 25 in the denominator. So I end up with an instantaneous rate of change of my f of x equal 1 over x plus 3 when x is 2, comes out to be an instantaneous rate of change of -1 over 25. And that's how you find the instantaneous rate of change of a rational function at a specific x value.